Hey everyone, another day, another devlog, and this one is a cool one because as you can see here, I'm running a script and this script is, oh, I need to remove this. Anyways, is very familiar to most of you because it is the API, it is literally the API that we've been using to make the rest of the game, but this time in Python. So does it work? Let me actually click here to run, and it generated the code. 1 second. I will talk about that in a moment, but as you can see, we do have a window being generated. And talking about a window, I need to close my physical window here in the office to record. Anyways, we do have a window here, and this window was generated by this API, meaning that yes, the entire API of the engine of the library is actually reflected into Python, so we can do everything we want. So everything that is possible to do in the API, in the regular API, if you remember here, our old editor, we will be going back to this very soon, probably after this video. We do create like the window and the events, and this is of course a small subset of this, because I was just testing some stuff, but as you can see, it is working just fine. And how does this work? Whoa, there was a big advancement between the last video and this one. It's actually very simple, and I don't want to go into a lot of details because implementation is hard, but again, I will try to release this on my Patreon if you want to read the entire implementation details, or if you want to have any questions or comments, leave in the description. But I will talk a little bit about how this works in a superficial way, just for you to get an idea. So I do have this class interpreter inside this Py namespace, because I decided to call it this way. And basically, this interpreter can run scripts, but it does have all the magic happens in this register API. What is this register API? If you look here, you can see it is a function that I'm taking the virtual machine that PocketPy provides, and then I'm creating the dynamic math, physics, and event submodules, and then I'm registering the classes. How many classes? All of them. So you can see the audio class being registered here, and then I do have a constructor for this, a new, and it does support operation function overload or method overload. But you can see that I'm checking what I'm passing to Python and constructing the audio class accordingly with the cast and everything, and then I have error checking and so on. I have a get duration, and I also have sample fields here, which is variables of this class. So this entire audio class here, you can see it does have 3 constructors, 1 function, which is the get duration, and 2 variables. I do have the same thing reflected into PocketPy. So you can see here 2 variables, 3 constructors here. It's actually 1 constructor, but 3 use cases. And I also have the get duration. Something I don't have at the moment is default parameters. So for example, let's see if the audio does have a default parameter for the sample rate, as you can see here, and it does not support this at the moment. So if I wanted to pass like a sample rate, I will have, if I wanted to create an audio, I'll have to pass this. But this is easy to fix. This is not a huge problem. And again, I'll work on that later on. But the big part here, the most important part is I have this for every single class that I've created. And as you can see, this file is huge. It is actually, let me go to the, oh, here's the binding for the keys. I don't have like a better way yet to do this in PocketPy. I'm pretty sure that there is, but I just turned the enumerations into functions that returns the enumeration itself. Not ideal, but I'll change that later on. But as you can see, I do have almost 2,000 lines of code. And how is this possible? And what if I change anything here in the file? What if I create like a new stuff, let's go back to the audio. What if I create something like Boolean test? Does it work? Will it work? Will it be, do I have to do this? No, I can actually build this again and can see here that there's a bunch of stuff being printed out to the console. But if I go back to the generated code, you can see that the test is here. How is this possible? Well, it's because what is being printed to the console, this is only printed in the debug mode, is that I have a meta program that is executed and crawled into this directory, which is like the engine include directory for Dynamy, as you can see, and it it parsed 24 headers, and with those 24 headers, it created 23 classes, 32 variables for those classes, and 151 methods for those classes too, and 23 regular functions that does not belong to anything. And yes, this is a meta program. This is auto-generated, meaning that I did not have to write all this 22,000 lines of code. It was auto-generated by another program. And how this work? Well, I actually, in the engine here, I do have a pre-built event that calls a huge Python stuff, but it is actually calling a Python script that I created called scripting registry. And this Python script is actually parsing everything and generating the files. Let me quick show you. Again, I'm not going into any details here, but it is writing to this output. And I do have some helpful function. I'm using C++ CPP header parser, which is a great Python library for parsing C++ headers. And now I'm getting all the header files and parsing everything. And I'm literally generating. So this is, let me try to find a function. This is a function. So I'm iterating over all the functions. And then I'm literally adding to the code more code. So this is a code that generates code, and this is very useful and very helpful when it comes to programming. And this is very interesting because this is very used in the gaming industry in general. I use this in not gaming industry, actually game engine development industry, because there's a lot of stuff that you need to generate, and this is just tedious, boring, repetitive work. So it's a good idea to write a script that does that. It does not need to be pretty. So this script is not pretty. It's not like modular or whatever, but it does a job. So this is important. Like I have this very gigantic function that even have some copy and paste and some hard-coded stuff. For example, this is the initial part of the code. I don't need to procedurally generate this. I can just pre-made this. And if you go ahead here, you can see this is part one, which is here. Then I have an include space that later on I will add all the includes that is necessary to do this. And then I have this cancast function, and then the beginning of my interpreter racer API, and this is all pre-added here. And then what is important is like the middle of this class, which is from here until the end. This is all pre-generated. This is all like procedurally generated by the meta program. So yes, my engine, and I do this in Cave too, this is very good. You can see I'm mapping C++ operators to Python operators, and I'm not sure about those two here because this is not a thing in Python. It do not have like assignment operation, so yeah. Sorry, my bad. And this, I don't have a good alternative for that. But anyways, I mean, I do have, I believe it's the grep. I don't remember. I believe it's like, let me show Notepad. I believe it's this, but I will have to write some extra code to do this, and I'm not in the mood to do this right now. So I have it here. But anyways, I have some statistic here, which is the ones that I just showed you here, just to keep track of what's going on. And then again, it generates everything. And this allows me to very easily maintain a very large code base without having to worry about this being reflected to the Python scripting. It is always up to date, it is always good and ready to go, and I can use everything in the engine in the Python version, which is awesome, right? Some important things, PocketPy does not have support for std, so I'm using std string and std vector. It is not supported, so I need to write like a workaround. Let me actually show you an example. The font here, it can receive a path. If you remember my font class, it can receive a path, a file path, or like the build atlas too, but I'm here talking about the constructor. And it is a string. You can see and can cast to a Python string, not an std string. And then if I do actually create this thing, I'm actually casting to a Python string, and then I'm using this handy PocketPy str to convert to an std string, which is great, right? And then this std string can be fed into the font constructor. So I do have some conversions here that it is going on, but again, it is all handled by the meta program. So you can see here I'm checking if the type is a string, and then I'm doing the necessary changes here. Anyways, and I will do the same thing, not now because I feel like moving on for a bit, but I need to do the same thing for the vector, because while we do not use a lot, we only need to set the pixels. There's a function in the image to set all pixels at once to a given color, and it takes a vector of colors, and this won't work because PocketPy does not know about the std vector, but it does know about pkpylist, which is a Python list. And then what I can do is translate this vector into a Python list, and vice versa. In this case, it's vice versa because the function that I'm calling to the image, and if I'm calling from Python, I'm passing a Python list as an argument. So what I need to do is to grab this Python list and build an std vector of colors with this list and try to set this. And it's important because the Python list can have any different types of things. For example, I was testing some stuff here, some string formatting, but I can have a list that have an integer, and I also have a string, and I also have a boolean, and I also have another list or a dictionary and wherever. And this is of course not a thing in an std vector. So in this conversion process, I also need to go ahead and say, hey, are all the fields in this list a valid color, for example, in this case here? And if it's not, I need to throw to make a type error, say, hey, the parameters are invalid. So yeah, this is the thing, but it's not hard to do. I'm not gonna do it right now because I want to move on a little bit to finally go to the editor part of this agent, but we are in a good spot here because we do have everything generated. And I also plan to use this meta program, since I'm really working on it, to do serialization. I hope I pronounced this correctly. Anyways, which is, I do have all these classes here that we created, but how to save this to disk, how to save the image file into disk. It's a bit complicated. I need to save all the pixels and this and this. So yeah, it's necessary to save this and did the pixelated too. So I might do a meta program to do this. I'm not entirely sure about this, to be really honest, because a bunch of stuff here is very dependent. Like in this, for example, in the image, I don't want to save the data. I just want to save this, right? And if I go, let's try the mesh, I don't want to save the data again, I want to save this, but this time is public, and the shader, oh, it's the same. But like, it does have some stuff that are dependent. For example, the math tree, I want to save only the values or only the rows because they're union and it's the same thing. I don't want to save everything twice, and it is a bit tricky to do this with meta program. It's possible. It is like an extra if statement, but it is annoying. So I'm not sure about the serialization, but we'll get there once we get there, and then I'll find out what's going on, how to save everything. But yes, so that's it, folks. I hope you enjoyed this serialization meta programming small showcase. The code is huge. Again, I'm not going into details, but yes, I think you got what is going on here. And now we have Python scripting. It is embedded, very nice, and it was very easy to do. The scripting only have a single header, which is the interpreter, and then the implementation, I do have the generated stuff, the interpreter itself, and a PocketPy, which is a hack. People hate me because I do this, but I don't like extra complicated build system, so I do this. It's a hack, it's ugly, but it does the job. Anyways, folks, that's it for this video. Hope you enjoyed, and if you have any questions or comment, leave them below, and I see you in the next one. Bye.